Hello, I am Johnny Taylor and welcome to this video where we will be going through an overview of the University of Manchester's data processing software for the single particle soot photometer. We have a few things that we're going to go through. Firstly, we'll go through the different file types that the SP2 logging software records. Then we'll have a look at the LabVIEW code, and then we'll go through the IGOR code. So first, let's have a look at the different file types that the SP2 records. So here is a folder that is filled with some of the files that have been recorded by the logging software when we've been running an experiment. We've got a log file which contains the instrument logs. We've got SP2B files which are the single particle data. That's the really important ones. We've got an ini file which just contains all the settings, and we've got an HK file which is the housekeeping data, which is things like how the instrument was performing at any particular time. And you'll notice they're all named with the year, the month, the day, and then for the SP2B files they're sequentially 001, 002, etc, etc. So I'll give you an example now. Let's first look at the housekeeping file. So this is a CSV, so we can just load it up in Excel and have a look at how the instrument was doing. And there's all different columns here. So this is time, we've got the sample flow set, we've got the sample flow measured, we've got the laser power, the concentration of incandescent particles, the sheath flow, the chamber pressure, the chamber temperature, laser power, all these sorts of variables recorded once every second. And we can load this up in the IGOR code to look at this in more detail. So let's not look at it now. We've also got the ini file, which is just the settings. So generally you don't tend to look at this. So you've got things like the software version that was running at the time. You'll have things like this flow rate set point and how the instrument software is set up. All these sorts of things. But there are things like 1 out of every 1. That's a useful setting, because if, for example, you set this to 1 of every 10, that means you only record 1 of every 10 particles. And that's a really important thing to remember, because if you don't remember that, then your concentrations will be wrong by a factor of 10, for example. So that's something that you definitely need to check. But it should also be in your notes. So I'll show you the log file, but generally this isn't useful. It's just full of rubbish. I've no idea what any of this means. Alarms, no idea. You can have a look at things like when different files were started, but I've never used that for anything useful. So we'll get rid of that. And then we've got the SP2B files, which contain the single particle data. Now these are, I believe, a binary file, so you can't just load them up very easily in anything. So IGOR can't load them, for example, so it's just full of meaningless rubbish if you look at it using a text editor. So we need to use the LabVIEW code. So having loaded that LabVIEW VI in, we are presented with this panel, and there's lots of boxes and things here, but we can't actually do anything with any of them. The only thing we need to worry about is this little run arrow here, which we click on, and we get this dialog. Select the SP2 data files to process. So we need to navigate to the folder that our files were in here, and this is now a list of all the SP2B files that were in that folder, and you can add them one by one, you can remove them one by one, you can add all, you can remove all, you can double click. What I'm going to do is I'm just going to add all, and then I'm going to process the files, and then we choose whether we want the analyzed files to go in the same directory or a different directory as the raw files, but I'm going to choose the same directory and click OK. And so now what it's doing is it's going through that list of files that we've just selected, and you can see the input file and the output file, and you can see that it's going through each particle in the file one by one, and what it's doing is doing things like fitting peak heights and peak widths and that sort of thing. So while that's running in the background, I'm going to load in one of these XLS files in Excel just to show you what the output is of the LabVIEW code. And it's going to give this error, and you just do you want to open the file? Yes. So if you remember, the .sp2b file was this horrible binary file that we can't open, but this is now a file that we can open, and it's just a CSV, I think. You have event 0, 1, 2, 3, 4, 5, you have the time that the particle was measured, and you have various columns of flags of the peak height and area and fit position and full width, half maximum, offset, and these sorts of things. Lots of different properties of the fits to the individual particles. So if you want to know some of the things that's going on here, what these fits are, we can have a load of the other LabVIEW software VI, this SP2 Data Reader 8 channel. So whereas the first one is going through the files and automatically doing fits to all the particles in the file, here with this one we can look at the raw signals from individual particles one by one and see what's going on. So again, there's lots of things going on this panel, but the only thing we need to click is this little arrow for run, and then we ignore that, and we get a dialog asking which file we want to load. So I'm going to load in my file, and I know that this file is actually for PSL, so we're just going to get scattering particles in this file. And so you can see the measured scattering peaks on the high gain and the low gain channel 0 detector. You can see the measured incandescence peaks from the, I think this is the broadband and the narrowband. It might be the high gain and the low gain broadband actually. Anyway, and then you've got the split scattering detector as well. And so you can scroll through the different particles and you can see how the fits are, and you can play around with the notch position and see how that affects the leading edge fit and that sort of thing. And if you want to know what some of these numbers mean, I suggest you look in my thesis, and you can go here to page 61, and I've got some nice diagrams which show you what all the bits are for a purely scattering particle and then for a incandescent particle. So now that we have processed our files using the LabVIEW, we are going to load them in using the SP2 Igor code, and I'll give you some examples of the things that you can do. And I have here a copy of Igor running, and I'm going to open up this SP2 toolkit 1.75, and we get this dialog, and you just click compile, and then you get this thing at the top, SP2 and SP2 toolkit. Apply for default global variables, yes, and then you get this dialog or SP2 analysis. And there's lots of things going on here. Again, a lot of them you can just ignore. As with many things in Igor, the goal buttons are the big ones of the main things you want to do. So let's see if we can load in a file. So there's this thing at the top, load single file, or you can load all the files in a folder or a subset. We just want to load a single file first, and we're going to click load, and this gives us a box, and we can navigate to where we just analyze those files. So we've got all these XLS files here, and I'm just going to open that one, and it's loading them up. And if we look in the data browser, we can see we've got all of those things, all those column headers that were in the XLS file, peak height, fit height, all these things are now in the root folder. So this is all the fit properties for the individual particles, and you may have noticed that there was 41,362 particles in that file, and there's 41,362 rows in each of these waves. So that's each row in these waves is a single particle. And if we want to, we can discard this data and it all gets deleted, or we can load that again or load a different file. I'm just going to load the same one again. So the first thing we want to do here is, having loaded the file, we click filter, and what that does is it goes through each of these particles, and it works out whether you have a purely scattering particle or an incandescent particle by seeing if the signals are above the thresholds. And in this case we are using a file that was from PSLs, so we've got this pure scatter number. Pretty much all the particles were purely scattering particles, and some of them were incandescent, but given that we were loading PSLs, the vast majority are scattering particles. So now clicking that filter button has created these data folders for pure scatter particles or pure incand particles. I'm going to go through pure scatter particles because we've got PSLs. So you've got all these different things, the peak height and the peak width, the leading edge fit, the low gain peak height. At some point I will try and document what all these mean separately, but I'm not going to go through them now. And what I'm going to do actually is I'm going to load in a file with Aquadag, because then we'll get lots of incandescent particles. So we'll load that in and we'll click filter, and here we see the pure scatter number is very low and the pure incandescent number is very high. So I'll have a look here then at the pure incand particles, and you'll see that, so the incand number here 49,730, and there are 49,730 rows in all of these waves. And here you've got things like pure incand peak, that's the peak height for the high gain broadband incandescence detector. Pure incand peak LG, that's the low gain broadband detector. The narrowband detector, the low gain narrowband, the leading edge fit for the incandescent particles. So what this filter button does is it splits you into your scattering particles versus your incandescent particles. So what we're going to do now, I'm going to discard this single file. We're going to load all the files in the folder, and so that this is the folder that we were in. Select folder, and now we're going to load up all these files one by one, and you can see the individual files that we're loading in. So we've loaded them now, and again we click filter to split the particles into the incandescent particles and the purely scattering ones. And we're going to move to this next tab, and I'm going to load in the housekeeping data. That's this load HK button. Again, we've got a box for load a single file or all the files in the folder. I just want to load a single file, So I'm going to load the housekeeping. We were in this folder and we want this .hk file. So we can open that. And what this has done is, if you remember earlier on I showed you the housekeeping data in the spreadsheet, this has now loaded it into Igor waves. So you've got things like the chamber pressure, the chamber temperature. And this is in degrees C, so you can see that changing with time. You've got the number of incandescent particles as measured by the instrument. This is just a rough number. You've got the laser voltage versus time, and then HK time, that's the time wave for the housekeeping data. So there's various different things for the instrument. So now, having loaded in the housekeeping data, what we want to do is we move on to this section. So here's the numbers for the calibrations, and in a subsequent video I'll show you how you get these numbers and what they mean, but just we've got some numbers that are there by default, so we don't need to worry about that at the minute. And we're going to click this button, generate single particle size. Now this will ask you for an Igor experiment, which is an experiment that is pre-compiled that contains some me tables. So what this button does is it takes your calibration values and it takes the raw signals and it works out what the mass of the particles are. So if you look at this calibration, BC mass equals this factor times by the channel 1 signal, things like that. So when you look at all the different channel 1 signals, you use this calibration to work out the BC mass, and you've got a similar sort of thing for the PSLs, and that's partly what the me tables are for, because that tells the instrument, the software, sorry, how the scattering cross section varies with size. And so now if we look in these data folders now, I'll go to the scattering ones first, where before we just had these pure scatter peak, these essentially the voltages measured by the instrument, and now we've got things like scatter diameter, and this is in microns. And you've got scatter volume as well, which is in some unit of volume. And then for the incandescent particles, we did just have this pure incand peak, which is now turned into incand diameter. So again, this is the core diameter, and that is in microns. And there's various other things: the core diameter from channel 1 or channel 2, or the scattering diameter, the incandescent mass, so that's the mass of the individual particles. But again, this is on a particle by particle basis. This is single particles, and we've got like coating thickness, shell to core ratio, scattering enhancement factor, these sorts of things. So the next thing we can do, we go to this data analysis tab, and let's generate some time series. So we have averaging time here of 5 seconds, which is fine, whatever. And then there's this box here, correct for collection efficiency. So if you remember back earlier in the ini file, I said about that 1 in every X factor. So what this box will do, I think you should always have this ticked, because this will correct for that. So if you were just measuring 1 in every 10 particles, this will multiply your concentrations by 10. In this case, we were measuring 1 in every 1 particle, so we were measuring all the particles, it doesn't matter. And then there's other boxes that you can generally ignore or not if you wish. So let's generate a time series of the scattering particles. So this gold button, analyze. And that's been very quick. And now we can click data filter and concentration. And what this does is it just gives you a time series of the scattering particles. Now this one looks a little bit weird because we were doing a calibration, but what we can do here is just have a look in some more detail, and you can see, so this was when we had our PSLs going into the instrument. We were recording data. So it's just a time series, the number of particles, or the concentration of particles going into the instrument. And we can also have a look at the incandescent particle analysis. Click the Analyze button, and this one normally, this takes a little bit longer, but still not too long. And then again, data filter and concentration. And here it looks a bit more interesting because we've got here several different sizes of aqueduct that we did in the calibration, and you can just see how so this up and down is when the instrument was saving particles, and then you change the size and then you stop saving, you change the size and start saving again, stop saving. So that's what these spiky bits are. And this is the black carbon mass concentration, this one, and the black carbon number concentration. And these are stored in the pure incand particles folder. You have incand con for the number concentration, and incand mass con for the mass concentration. And the time wave for these time series is by default this HK time av incand. And in the scattering folder you have waves for scatter con versus, where is it, HK time av. So what we can do, for example, we can go at the bottom, display incand con versus HK time av incand. Let's make this black because it is incandescent particles. And let's go into the scattering folder, and at the bottom append scatter con versus HK time av. So this is now our two calibrations put together. We've got the PSLs here, the scattering particles from ScatterCon, and then we've got the aquedag, the incand-con, the incandescent particles as a time series. And there's various other bits around here that you can play with, but I think for now that's all we're going to go into. So that concludes the first video of this series, and hopefully you'll now have an idea of the big picture in how to process SP2 data, how all the bits fit together, if not necessarily the fine detail of how all the bits work and what all the boxes do. So thanks for watching.